One model isn't good enough? Use many! Ensemble learning is where you combine the predictions from multiple models to decide what to output. The idea here is that if most models think it's one thing, it's more likely to be that thing than if just one model did. Just like when you ask 100 people in the US, what is the capital of Texas? You'd expect that some people wouldn't know, some people would get confused and say the wrong city, but overall, you'd expect that the most common answer is Austin, the correct one. In ensemble learning, you are trying to do the same thing. Use the wisdom of many to fill in the gaps of the knowledge of the few. Two common methods for how to combine the predictions of your model are majority and summation. In majority, you simply choose the answer that most of your models choose. In summation, you add together the probabilities of your predictions for each class and every model, and then you choose the class that has the highest sum. Note that while majority and summation often produce similar results, there can be slight differences. Say, for example, you are trying to predict whether a picture is a dog or not, using an ensemble of 5 different models. The outputs are as follows. Models 1, 2, and 3 are 60% sure it's a dog, and 40% sure it's not. Models 4 and 5 are 20% sure it's a dog, and 80% sure it isn't. Notice here that if you take the majority vote, you would classify this picture as a dog, as 3 out of 5 models think it's a dog. However, if you sum up the total percentages, you'll notice it predicts not a dog. Why use summation? Why not average? Averaging would give the average probability for every class, whereas summation doesn't really feel like it means anything. Summation is actually a proxy for average. If you divide two things by the same number, the larger of the two will always be larger, so we can avoid doing the division. If we go back to the dog example, 220% over 5 is 44%, and 280% over 5 is 56%. So you still get the same prediction. Therefore, we can use summation instead of averaging, as all that does is save us one operation. Soon, I will cover ensembles performed using bagging and boosting. Subscribe.